Hey everyone. So in this video we'll discuss about LU decomposition. So LU decomposition means they will give one matrix to you, either it's 2 by 2 or 3 by 3. They'll ask you to find the LU decomposition. That means what you have to do is like you have to convert the matrix into lower triangular and upper triangular product. So in this case, let's assume so they'll give one matrix like 2 1 4 1. So you have to convert that into lower triangular. This is the lower triangular and this is the upper triangular. If you do that, then it is known as a LU decomposition. So there are two ways to do this LU decomposition. One is Crout's method, another one is Doolittle's method. So I have, before going to that, I'll explain about what is lower triangular and what is upper triangular matrix. If you consider lower triangular, the elements which is present above the diagonal elements are zero. So consider this example 2 by 2. So this is the diagonal. So whatever the elements which is present above the diagonal are zero, then it is known as lower triangular. And if it is upper triangular, the elements which is present below the diagonal elements are zero, then it is known as upper triangle. So uh, so they will these are the two ways, like one is Crowd's method, another one is Doolittle method. So this is the simple formula. You have to remember just by the name itself indicating L means lower triangular, U means upper triangular. So you will mention, like, obviously this condition, the elements which is above the diagonal are obviously zero, so you put that one. And this is normal L11, L22, L21, L22. So these are the normal elements indexes. And after that, consider this upper triangular, make this diagonal elements as 1. Then this 0, obviously, by upper triangular definition itself you get this 0, and make this as a U12. That's it. So in the same way, consider Doolittle also. First we'll discuss about Crowd's method, then we'll discuss about Doolittle method. So uh, so so this is the way, this is the formula you have to remember. And you have to apply this product, like, first row, first element into this second matrix, like, first row first element, you have to product that. And basic this one, like, you have to do this matrix multiplication and you will get these values, uh, like L11, then after that L11 U12, after the 0 into 1, so 0, then so these things you have to do. You first technique is like you have to equate that whatever matrix given to you to these elements, and after that you have to solve those equations. So if you solve those equations, then you will get the remaining corresponding elements values. And uh, you know so just consider these examples. So given this matrix and you are equating with these equations, and you are solving these things, so that you can understand like what is L11, L21 and L22. So these things are somewhat directly available to you. After, in order to find the unknown ones like U12, you have to do some calculations. So after getting these things, you have to arrange the elements in this form. That's it. So simply you can solve this one. So this is a direct method. There is one shortcut also there. So in Crowd's method, you have to do the column operations. In Doolittle's, you have to go for the row operations. Column operations means, you already know. So this is the format you want to, this is the format you are looking for. Your aim is like you have to convert this matrix into in this form. So obviously you have to convert this element as a 0. And by default, these things, this is a static kind of static, so it won't change. 110, it won't change. So your target is to make this element as 0, and after that, you have to figure out this U12. The rest of the elements are same. So what you can do, so you can apply some column operations. Why you are If you're going for a Crowd's approach, you have to implement the column operations. So this, your target is to make this element as 0. Then what is the value, like C2 minus half into C1. So then this one becomes 0. You'll get this kind of a matrix. Then you have to arrange this thing in this form. So by default, these are the same things. It is already in the this format. You have to figure out like what is U12. So whatever operations you perform, you got one value, right? You have one sign also. Take the opposite sign of it. So here you got minus 1 by 2. So make it as a 1 by 2 plus 1 by 2, because opposite of that. That's it. So you can able to convert. You can look the above example also. If you go with a direct approach, also same answer. If you go with a shortcut technique, also same answer. So This is the way you have to do with the crowds. Then Doolittle. So Doolittle also same thing. So just remember one thing, then the exact opposite. So L means obviously you have to do the lower triangular. A lower triangular means the element which is above the diagonal has to be zero. This is fixed. And after that, instead of making L11 L22, make this as a 1 1 diagonal elements as 1 1. And after the rest of the element, you obviously, then same thing. It's if you compare this one, same thing. You have to modify the this format in that format. That's it. So this is the Doolittle one. I'll give one example on 3 by 3 matrix. Then you'll get some more clarity. Okay, it's taking some time to load. Okay. Okay. See, guys, so this is a Doolittle one only. So you have to arrange this in the Doolittle. So then, I already told you, if you are going with the Doolittle, you have to do the row operations instead of column operations. So here, your end result is like you have to make this element as zero. So here you can see this element, you have to make it as a zero. So how are you going to make this element as zero? By performing some row operations, like uh, you know so r2 minus 2 into r1, so this element becomes 0, so this will be in this format. And by default, this 1 1 0, these things you already know, you don't need to change anything. L21 is like whatever operations you done, opposite sign of that one. So here you got the value. So this is the u1, u matrix you already got here, so apply here. So that's it. So 3 by 3 also same thing, you have to perform this um select that matrix, and after that you have to make this elements as zero. By the way, this is a Crowd's method, it's not too little one. And so if here one trick is there. So if already the element is zero, then you don't need to touch anything, so let it be. So focus on the remaining elements. So in this case, you are applying c2 minus 2 c1, so that it will become 0, and after that it's already is there, so you don't need to worry about anything. So you're focusing on this column, so it is done. After that, you have your target is this one. So by using this column, you are making this column as 0. So it's already so if you look at this, the elements above the diagonal are 0, then it is a lower triangular, you got it one. So then upper triangular you have to fix already, so 1 1 1, after the 0 0, this is fixed. Then these elements you have to fill. So how we are going to fill whatever operations you done first now, so make this one opposite sign. So 2 you got. Then next you didn't done anything, so that's why you make it as a 0 only. Then after that you performed here one minus operation, that means plus. So that's it. So in the same way, I'll tell you one more example on this one. It's taking some time. Okay. So this is a Doolittle example. Earlier we experienced, like we explored Crowd's method. So this is a Doolittle one. So 3 by 3. So you have to make it as a LU, and after that you have to perform the row operations. And once you've done, you got that value like this. So that's it, guys. And so ultimately what matters is, like, they'll give one matrix to you, they'll ask you to convert that matrix in a LU decomposition. That means you have to convert that matrix into combination of lower triangular and upper triangle. That's it.